Okay, so we're basically asked to determine continuity for this function right here, decide where it's not continuous. So notice the numerator is almost exactly the same as the denominator, as the numerator says the absolute value in it. To figure out what the graph of this thing looks like, you might want to make a table of values and just sort of see what the output values are going to be. So the problem value here is, I think, fairly clearly going to be at x equals -2. If you plug in -2, you're going to get 0 over 0, and that's undefined. So let's plug in values that are kind of around -2. Let's go -4 and -3, and then let's put in values that are slightly bigger than -2. So we'll go -1 and 0. Okay, so notice if you plug in -4, what's the output? Well, -4 plus 2 is -2. Take the absolute value of that, you get 2 though. And you're going to get the same thing in the denominator, except it's going to stay negative, so we're going to end up with a -1 there. And you'll notice that the same thing is going to happen no matter what value I put in that is less than -2. So for -3, the same thing is going to happen. -3 plus 1 is -2, so I'm going to have a -2 in the denominator, and in the numerator I'm going to have a +2, so I'm going to get -1 out of that too. And on the other side of -2, just notice what happens there. There the absolute value is not going to have not going to make any difference, because whatever number I plug in that's larger than -2, I'm going to get a positive number in the numerator, and the absolute value of a positive number is still positive. So for example, -1 plus 2, that's 1. Well, absolute value of 1 is 1. Same thing in the denominator, I'm just going to get 1. So, and that's going to happen really for any value of x that's greater than -2. So what the graph overall looks like is something like this. So at -2 we've got that problem value, but all the other values of x there's no problem. So the output for any value of x that's less than -2, here's our -2, is going to be -1. I'm going to put an open circle because it's not defined when we actually plug in -2. And then when you go to a value of x that is bigger than -2, you stay constantly at 1. So really that's what the graph is going to look like. It's basically just horizontal line going out to infinity at +1 for all values of x that are greater than -2, and then horizontal line going to -infinity for all values of x that are less than -2. So that's what the graph looks like. And clearly you can see from the graph that we've got a jump discontinuity at x equals -2. So there's only one discontinuity, and it happens at -2. So there's a discontinuity at x equals -2. And the reason for that is if you take the limit as x approaches -2 from the left, as we see on our graph here, that's going to be -1. And if you take the limit as x approaches -2 on the right, you see from our graph, and also from our table for that matter, that the limit is 1. So because these two limits are not the same, that means that the limit itself doesn't exist. The limit as x approaches -2 does not exist. Okay, and that's why we have a discontinuity there, because this limit doesn't exist. So hopefully that helps with this type of problem.